Look up at the moon tonight. For most of human history, we have seen it as a cold, dead rock, a beautiful nightlight, but nothing more. But as we stand in 2026, our perspective is shifting. Scientists now believe the moon is actually a giant cosmic battery filled with substance that could slow Earth's energy crisis forever. It's called Helium-3. It is rare. It is incredibly powerful. And right now, the most powerful nations on Earth are in a race to go get it. But what exactly is it? And why is it worth billions of dollars per ton? To understand Helium-3, we have to look at the sun. The sun is constantly blasting out a stream of particles called the solar wind. One of those particles is an isotope called Helium-3. On Earth, we almost never see it. Our planet has a thick atmosphere and a strong magnetic field that acts like an invisible shield, bouncing Helium-3 back into space. But the moon has no shield. For 4 billion years, it has been sitting there, soaking up the solar wind like a sponge. Now, regular helium, the stuff in birthday balloon, is called Helium-4. It has 2 protons and 2 neutrons. Helium-3 is its rare cousin. It has 2 protons but only 1 neutron. That missing neutron is the secret source that makes it the ultimate fuel for the future. Today, every nuclear power plant on Earth uses something called fission. This means we take heavy atoms like uranium and we split them. It creates a lot of heat, but it also creates radioactive waste that stay dangerous for thousands of years. But there is another way, fusion. This is the process that powers the stars. Instead of splitting atoms, we fuse them together. Most fusion experiments today use 2 types of hydrogen, deuterium and tritium. The problem: this reaction shoots out angry neutrons. These neutrons are hard to control. They damage the reactor and they create radioactive bypass products. This is where Helium-3 changed the game. When you fuse Helium-3 with deuterium, it doesn't release those angry neutrons. Instead, it releases protons. Protons have a positive charge. That means we don't have to boil water to turn a turbine like a 19th century steam engine. We can capture that energy directly into a wire as electricity. It's cleaner, safer, and nearly 100% efficient. So, what is this starfall actually worth? Right now, a single ton of Helium-3 is valued at roughly $5 billion. Just even 5 tons, about the size of one space shuttle cargo bay, could power the entire United States for a full year. But it's not just about power plant. In 2026, Helium-3 is already the gold of the tech world. It is essential for quantum computing. These supercomputers need to be kept at temperature colder than deep space to work, and Helium-3 is the only substance that we can get them there. But there is a catch. To get just 1 ton of Helium-3, you would have to mine and heat up over 100 million tons of lunar soil. It is ultimate high-stake mining operation. Because the stakes are so high, a new race has begun. This isn't just about a plant in a flag anymore. It's about energy independence. The United States, through NASA's Artemis program and private companies like Interluna, is mapping the lunar surface to find the richest hotspots. Meanwhile, China has already successfully brought lunar sample back to Earth to test their extraction method. While some worry about lunar war, most experts see it's a competition of technology. The nation that masters the moon's resources first will likely lead the global economy for the next century. It is not about who has the biggest army. It is about who has the best gas station in the sky. For 60 years, we look at the moon and saw a destination. Now we see a solution. Helium-3 reminds us that the answer to our greatest challenge on Earth might just be hidden in the stars. The next time you look at the moon, don't just see a rock, see the future of energy.